Java is indeed widely used for application development, but developing data processing task is not simple. For example, grouping by two fields and performing aggregation need to be implemented like this. Compared to that, SQL is much simpler, with just one group by statement. Early applications really did work with the collaboration of Java and SQL, but this framework was difficult to scale and migrate due to database limitations, and SQL was unavailable when there were no database or cross-databases. So, later on, many applications also began to adopt a full Java framework with databases only doing simple read and write operations, which could gain framework advantages, but also face the development complexity mentioned earlier. Development and frameworks seem to only be able to focus on one aspect. To enjoy the advantages of frameworks with Java, one must endure development difficulties. On the other hand, using SQL requires tolerating the shortcomings of the framework. This presents a dilemma. What about enhancing Java's data processing capabilities? This not only avoids SQL issues, but also overcomes the shortcomings of Java. Stream, Kotlin, and Scala under Java are all trying to do so. The stream introduced after Java 8 has added many data processing methods, which can indeed simplify the calculation code. But overall, it is still cumbersome and far less concise than SQL. Kotlin, which claims to be more powerful, has further improvements, but it is still not enough, and there is still a big gap compared to SQL. Scala is a bit simpler, but still cannot be compared to SQL. Moreover, Scala is too heavy and inconvenient to use. Additionally, Java, being a compiled language, lacks support for hot swapping. Modifying code necessitates recompilation and redeployment, often requiring service restarts. This results in a suboptimal experience when facing frequent changes in requirements. In contrast, SQL has no problem in this regard. Java development is complicated, and there are also shortcomings in the framework. SQL is difficult to meet in framework, and the dilemma is difficult to solve. Is there any other way? There is Spark SPL, a data processing language developed purely in Java, which is easy to develop and has a flexible framework. Looking at the grouping example earlier, it's evident that SPL code is much simpler compared to Java, akin to SQL. In fact, SPL is often simpler than SQL. Due to its support for ordered and procedural calculations, SPL excels at performing complex computations. For instance, consider this example. Calculating the maximum number of consecutive rising days of a stock, SQL requires 3-layer nesting, which is complex to write and understand. In contrast, SPL can achieve the same in just one line, making it much simpler than SQL, not to mention Java. SPL provides a rich computing library that can handle grouping, sorting, filtering, and join, enabling quick implementation of all data processing tasks. The computing capability of SPL is independent of database. It can function even without a database, unlike O or M technology, which requires translation into SQL for execution. SPL also supports big data. It can compute whether or not the data can fit in memory, and parallelism is also easy. Adding N at M option is okay, which is much simpler than Java. SPL has a comprehensive development environment with clear calculation results for each step, making it particularly user-friendly for debugging. SPL is developed in Java, and it can be used within applications once importing its jars. SPL scripts are executable and callable via standard JDBC, making it lightweight. It can even run on Android. Of course, it can also be seamlessly integrated into mainstream Java frameworks, especially suitable for serving as a computing engine within microservice architectures. SPL is also convenient for handling scenarios without or with multiple databases. Regardless of the data source, as long as it is accessible, SPL can read and perform mixed computations. Database and database, RESTful and file, JSON and database, anything is fine. SPL is an interpreted language that operates in real time, without requiring service restarts after code modifications. It inherently supports continuous hot swapping, adapting well to dynamic data business requirements. This capability enables independent computing modules with separate management and operation, enhancing flexibility and convenience in usage. SPL is now open source. Please feel free to download it.